So, welcome back. So, in the last session, we have discussed about how file handling works, and we have seen the various ways to handle files, like different kinds of files. It might be text file, or image file, or a CSV file, or different kinds of files. And we have seen various operations like how to remove, rename, and also we have explored about context managers. So, in this session, let's focus on exception handling. Before talking about what exactly is exception handling and what exactly is exception, first thing you have to understand is what exactly is error. Okay. First thing you have to understand is what exactly is error. So you know what is an error, right? So whenever we write a program and when our output is not expected, or if there is any issue in the if there is any bug in the program, that is called as an error. And if I talk about errors, there are mainly three types of errors I should talk about. One is syntax error, we have syntax error, then we have something called as runtime error, and we have something called as logical error. So basically, these are the major three errors we face when you're working with programming. So first, let us talk about syntax error. So syntax error are kinds of error which occurs if you don't follow proper syntaxes while programming. So every programming language, not only Python, whatever programming language you are working on, every programming language will be having some kind of syntax to code. Okay. If you are not following that proper syntax, then you'll be getting the syntax error. Okay. So that is basically a clear-cut developer mistake. So let me show you how exactly syntax error occurs. I mean, a small example. Let's assume that you want to define a function called as add, something like that. Okay. And here I've just taken a simple function, and here I have mentioned like this maybe, and if I just say like this, print 10 plus 20. So here when I run this, I'll be getting a syntax error because I'm not following a proper syntax. Here I've missed this particular colon, which indicates that I'm starting a block. So as a function is a block of code, I'm not giving this colon. I'm getting a error called as syntax error. It's invalid syntax. So when you don't follow proper Python syntaxes while you're coding, that is called as syntax error. Or let me show one more example. Let's assume that you're trying to print a statement. So if you just say print some date or print hello. Okay. So here if I don't follow this proper syntax, that is if you are missing your parenthesis, it's a syntax error, because according to the Python 3.0, you should have print is a function, not a keyword. So you should call like this, then only it works, right? So when you don't follow proper syntaxes when you are writing your code, that is basically called as a syntax error. Okay, cool. And basically, syntax error can be easily solved by the developer if you know the syntaxes, if you know how to write the syntaxes for respective use case or respective program, you can actually avoid the syntax error, right? So syntax error is easily solvable. But here comes the main error, that is your runtime error, which we are talking about right now. See, runtime error are, as the name says, are the errors which occurs during execution. Okay, the errors which occurs during execution. So we know, right? Whenever our code is compiled, means not, of course, our Python is not a compile based language, but whenever our code is converted, then it executed, means it will get executes. It will perform the operations whatever you have wrote. Okay. So when you get an error while executing the current code, means when you're performing this execution, then it is called as a runtime error. Okay. Generally, this runtime error are in most of the cases they're unpredicted. So because, see, when you are writing a code, maybe that particular error you might not occur, but maybe because of the bad input by the user, or maybe because of the some other reason, you might get this runtime error. Okay, so let's see how exactly this runtime error occurs. Okay, let me show a small example of runtime error. Let's assume that you're trying to add two numbers. Okay, you're trying to add two numbers by taking the input from the user. So you define a function like this, def add. I'll take like this, a is equal to input. Okay, input of enter a number. Okay, a number, something like this, and b is equal to enter another number, something like this. Okay, and I'll just say like this, C equal to A plus B, and I'll just say print C. So I'm just taking a simple function which takes two inputs from the user and adds those. That's it. Okay. So I'm just calling this add function, and whenever I'm calling this add function, it will ask me to enter numbers. So I'll just say 12, and I'll just say 13. It will give me 12, 13. Of course, if I want to make it convertible, I have to convert into integer. For example, let's assume that I'm converting into integer and adding it, because I want to add only integers, and I'm asking my user to enter the user input only number. So I'll just say 12, 13, and see if my user has entered the number properly, I'm not getting any error, right? I'm not getting any error. By chance, if the user has not entered the number properly, for example, if I just said hello and if I just said 12, so here I'll be getting a value error called as invalid literal int hello, because here this particular value is not convertible into integer, because I'm entering hello, which is not convertible integer, right? You know that we will be getting a value called as value error. We'll be getting error called as value error. So basically what's happening here is, even though you are not making any mistakes in the syntaxes, because of the wrong input by the user, here in this case, you are getting an error. One more example of runtime error is, for example, let's assume that you have a file here. Let's assume that you have a file called as maybe random.txt. Okay, you have a file called as random.txt, and let's assume that you want to use this particular file. Okay, so let's assume that you are just said maybe with open. I'm using with context manager. So with open, maybe random.txt comma mode is equal to maybe RB or R maybe, and I'll just say, so I'm opening the random.txt in mode R, and I'm just reading the contents from the file. So I'm just saying f.read. So here also there is no error in the syntax, right? And yeah, so here of course there is a small error, that is I have to use f. Okay, so you can see here there is no error in the syntax, and you can see here I'm able to get the contents in the file like this, f.read. If I say print f.read, I'm able to print my contents in the file like this. But let's assume that some of the user who is using your application or someone has deleted this particular file mistakenly, or let's assume that due to some problem this particular file got deleted. Okay, I'm just deleting this random.txt file. See, it's not your mistake, because this code is running, but by chance if you file got deleted, because R mode will not help us to create a new file, right? You would get a exception called as file not found error. So this is called as an exception. Okay, so basically runtime error is nothing but called as an exception. So here in this particular case, you as a developer, you are not what we call making this mistake, but due to some kind of other factors, you are getting this particular mistake. Okay, you are getting this particular error. Okay, before going proceeding further with the exceptions or runtime errors, let's focus on logical error also. See, it's very simple. As the name says, if you make any mistakes in writing logic, for example, let's assume that we discussed about recursion, right? When we were discussing about functions, we discussed about recursion. And let's assume that you made a small mistake, logical mistake in the code, and because of that, your input is not as expected. That is called as a logical error. So the mistake you have done due to logics, that is called as logical error. Let's take a small example here itself. In recursion, for example, here you are trying to let's assume that you have a factorial of a number. Okay, you're trying to find out a factorial of a number. So here instead of n, if I'm just saying return 0, so here I have done a logical mistake. So there is no syntax error, there is no runtime error, but the output what you are getting is not expected because the logic is wrong. Okay, so whenever you make an error in the logic, or whenever you made an error in the mistake in the logic, that is called as a logical error. Okay, so basically syntax error and logical error can directly solved by the developer itself, because if you properly write a logic and if you properly maintain the logic, you'll not be getting any kind of logical error, and if you properly write a syntax, you'll not be getting a syntax error. But exceptions, runtime errors are the kind of unpredicted, because there may chances of getting that particular error anytime because of the wrong input by the user, or because of some kind of other factors also. So to handle this, that is the reason we have a concept called as exception handling. Okay, we have a concept called as exception handling. So what happens here is, so first thing, why do we need exception handling? First thing is to avoid these exceptions. That is first thing. The second thing is, let's assume that in industry, when you're writing some code, when you're writing some program, you're developing some module, you'll be writing thousands of lines of code. Okay, and when you're writing thousands of lines of code, somewhere let us assume that there is a runtime exception or runtime error somewhere at second line or third line. Okay, automatically the remaining lines of code will be getting affected. Let me show a small example. Let's assume that here in this case, in our case, here I'm having an exception. Let's assume I'm taking this input something like this, a code. Okay, so just have a look at this. Okay, so I'll just say like this: print this is before, or this is sample text. Okay, I'm just printing a sample text. Okay, and after this particular, I'll just print some more text. Okay, sample text 2, maybe sample text 3, something like that. I just go on printing. So if we just carefully observe here, if my user is properly entering my input, I'm happily, my code is executed, and happily I'll be getting this particular output. But by chance my user is not giving a proper input, then I'll be getting error. See, okay, I'm getting error, that's good. But the thing is, I'm getting the error at fourth line, means at this particular line. At this particular line, I'm getting the error. But because of that particular error, the remaining 2 lines of code is not getting executed at all. See, you can clearly see that this remaining lines of code doesn't have any relationship with this code, right? Means it's not like only if I get this output, then only I should execute this code, or it's not like this particular code, this particular output depends upon this output, right? These both are independent of each other, but still, as this Python will execute sequentially, when you get an error at this position, automatically you'll be getting this particular part of code will not execute, right? So to avoid this particular problem only, we will be handling exception. So exception should be handled whenever a developer feels, let us assume you're a developer and you feel that there might be exception occurring at this particular place, you have to handle this exception. And how do you handle these exceptions? By using try and except block. Okay, so in Python we have something called as try and except. So by using this particular try and except block, you will be handling the exceptions. So let's see how do we do that. Okay, and remember, let's assume that you have 1000 lines of code, and second line, third line, you have an error. So remaining 900 lines will not execute, right? That is one of the reason. So let's see, in the same case only, I'll try to handle the exception. So let's see what happens. So what I will do is, I'll put this particular 3 lines of code in the exception, okay, exception handling. Okay, so what happens here is, this particular 3 lines of code which I feel that exception might occur, I'll be putting in try block. Okay, so a developer who feels that that particular part of code, my error exception might occur, you should put that in particular try block, in try block. And let us assume that exception has occurred. Okay, assume that exception has occurred. So if exception has occurred, then what is your resolution? What is your next immediate step? That should be done in the except block. Okay, so what happens is, except, so we have 2 blocks here, one is try block and except block. And remember everyone guys, except block should be always after try block. Okay, it should be attached, they are both like attachment. Okay, so first you should have try, then except. Okay, so immediately if you get any error in try, so what happens here is, whenever you get any kind of exception, any kind of runtime error in try, immediately your except block will handle that. Okay, will handle that. Okay, so except, and here whatever code you want to write. So I'll just say exception occurred. First I'll just print only exception occurred. Maybe let's see the other kind of resolutions later on. I'll just say print exception occurred. Cool. So in this way, you can see here I'm printing, I'm just trying to handle exception. So in this though, you'll be handling an exception. So you should put your whichever code you feel that exception might occur, you have to put in the try block, and whatever exception occurred, it will be going to automatically except block. So except, and one more important thing is, except block will be executing only when there is an exception. If there is no exception, it will just execute try block and just come out from that. Okay, so let's see. So now let me enter input 12, 13. You can see no exception occurred because this is perfect. So I'll also print C here better. Okay, so 12, 13. So I got result 25 and there is no exception occurred. So there is no except block has not executed. That is the reason you can see I didn't got any statement called as exception occurred. But by chance, if I enter hello and 12, automatically your exception occurs. So you can see here, the thing is, your app is not crashing here. See, what happens is, one more important thing is, let's assume you're developing an application, right? You're developing an application, and by chance, because of some error, because of some mistake, your exception occurred. There are chances that your app might also get crashed. Your application might get crashed. Sometimes you might see that app got crashed when you're using any Android application or something like that. It goes to not responding state. That is because of this kind of exceptions only, in most of the cases. So that way that you're handling it, so such that app will be running smoothly. However, if there is a dependency, you can write it in except block, but still, yes, so your app is running smoothly right now without any crash or something like that. Okay, so in that way you're handling your exception. Perfect. Okay, this is how you'll be handling exception. Now the next important thing is, right now in this case you're just printing that exception occurred, right? You're just printing that exception occurred. But if you want to print the actual message, what was the reason for exception occurring, then what you can do is, you can just I'm just copying this code and pasting here. But if you want to print the message, then what you can do is, you can do like this: exception, right? Exception. There is a class called as exception itself as e. So what you're doing here is, whatever exception you are getting, that particular exception you are taking in a variable called as e. Okay. So in this way, in this particular e, whatever error occurred, that will be stored. So you can print the message also. You can print, or you can see, or you can log it. So basically, we use logs, right? So you can just log it. You can just log this particular error. But let me print first and see what happens. So I'll just say print e. Okay. And if by chance 12, 13, no exception, maybe high and 12, yes, there is an exception, and it clearly says that yes, invalid literal for integer, means you are providing a wrong input to the integer function, right? Means typecasting, you're doing a wrong typecasting here, you're converting a string to integer, which is not possible. So that is, you're printing that e value. Okay, what is an exception? What is that exception? Okay, in that way you can see clearly in this way also. Okay, perfect. So let me show you this particular execution process, how exactly this works using Visualize Python. Then you'll be getting more clarity how exactly this works. Okay, I'm just opening the Visualize Python, pythontutor.com, and here I'll just copy this particular code and paste it there, and just see, let's have a look how exactly these particular exceptions are occurring. Okay, so I'm just going here and pasting here, and I'll just say visualize execution. So as usual, first it starts printing this. First it will go to try block. Okay, so it will ask me to enter a number. So I'll enter a number 12. Okay, then so you can see a variable called as 12 is created, but it is in the form string format, because we clearly know, right, input function by default will take any input in the string format only. So it is taking in string format. Then I'm giving 13 here, submit. So you can see B is also in string format. Now 12 and 13 are convertible integers. So it will properly convert into integers. You'll be getting 25 because you're converting into integers, you're printing C. You can see here, the moment it done with the try block, as there is no exception in try block, it is directly going to the next block and it is executing. Whereas if I start giving some numbers, I mean, if I start giving some string kind of data, okay. So for example, if I give I, submit, and maybe 13 and submit. So you can clearly see that here A is I and B is 13, which is actually A is not convertible integer. So just saying A of int. So immediately here you'll be getting an exception. At 6th line, you're getting an exception. You can see you got an exception here. So now whenever you get an exception at 6th line, in the try block, it will not go to 7th line, because whatever present in try block will assume that all these code are dependent to each other. So without executing of 6th line, if I go to 7th line, automatically I cannot print C, right? Because C is not created yet, because is not, I got an error here. So it will go to the exception, except. Okay, so you can see I got an error at try block. So it is going to the except block. So it is taking a variable called as E. So you can see in a variable called as E, a particular message will be stored, and you're printing that, and your exception is occurred. Finally, you're done. So in this way, you're handling the exceptions in Python. Perfect. Now, okay, you're handling a specific, I mean, you're handling all the exceptions. Whenever I say this exception, whenever I write this code, it can handle all the exceptions. For example, let's assume that here I have some other code in my try block. Maybe I'm trying to open a file which is not present. Okay, maybe something like this, file not found error, right? It's a file not found error. Okay, it's a file not found error. So it can handle all the exceptions. Now you can see no such file or directory random.txt. It's giving me the message also. But in some cases, there might be a situation where we should handle only specific exceptions, not all the exceptions, because whenever you write exception here, it will handle all exceptions. But maybe there is a chances where you might get multiple. There is a chances of getting multiple exceptions, and your resolution for specific exceptions will be something else. Means, for example, if we get a here, if I run this code, if I run this particular code, and if I give a wrong input here, if I give a wrong input here in by chance, I'll be getting a error called as value error. Okay. And if I run this code, I'll be getting an error called as file not found error, right? So both errors are totally different. So if you want to if you want to execute a particular code only when you get file not found error, or if you want to execute a code only when you get value error, then you have to handle this exception separately. So in that case, how do you handle? So if you want to handle only the specific exceptions, how do you handle? Means in this way. So let me copy this code, paste it here. And when you want to handle a specific exceptions, here instead of exception, you have to put it here as file not found error. So when you write your except block in this way, it will handle only file not found exceptions. By chance, if we get any other exceptions like value not value error, or maybe index error or something like that, index error or something else, so it will not handle that those all errors. It will handle only specific exception like this. Okay, so you can write like this: file not found error occurred, and you can just print the value of e. So when you want to handle that exception, and when you want to what we call do some kind of resolution, maybe let's assume that you're opening your you're opening your file with mode R, and you got file not found error. So you have to create your file only when you get file not found error. If you get another error, you should not create a file, right? So in that case, you can use this kind of thing. Means here, whenever I get file not found error, what I will do, I'll create the file. So how do we create a file? Using your X mode, right? So I'll just say f is equal to open of random.txt. Right. So you can see here, I'm creating the file only when I'm getting a file not found. So I got that yes, file is not found. So let me create the file. As simple as that. Right. If I get an error, I'll try to create a file here. So mode is equal to X. Okay, that's it. So here you are just opening here, and finally f dot close. So what you're doing here? You're just trying to create a file only when it is not present. So you can just run this. Yes, file not found error is occurred, and you can see. If I just go back and check, yes, you can see seconds ago random.txt was created. All right. So in this way, you are actually trying to handle the exceptions in an intelligent way. So that's where your specific exceptions will be helping us. Okay. Maybe let's assume that you have multiple codes in this. I mean, in real time, this is not the right way to write a code. I mean, multiple codes in try block, but let's assume that you have multiple codes in this. Okay. Just assume, okay, that for example, in this particular try block, I have like this, and this one also. I have this particular code and this particular code. And for now, for time being, again, I'm removing this random.txt because it was created again. Perfect. So now when I run this code, okay, for example, I'm giving a number hello. I'm giving as hello. And if I give I here, so here what happens is, if we just carefully observe here, what happens is, my error will be at this place, right? As my error is at this place, it will not even execute this part of code. So immediately, can anyone guess what happens here? Just guess it. Just try to guess this. So what happens here is, here I'm not handling a file not for, I'm not handling a value error. Here generally value error occurs because you're trying to convert a string to integer. Okay, I mean a text to integer, which is not possible. So automatically you'll be getting value error. But in exception handling, you're not handling that. You're only handling file not found error. So here my app will crash. Just carefully observe. App is crashed. You can see it is crashed. So the next line of code is not executed. Okay, because you're getting a value error, but you're not handling that. So how to handle multiple errors in that case? If you want to handle multiple errors, even that is also possible. Means, for example, if file not found error occur, you will be handling in this way. There is chances that value error might also occur. So you will be handling multiple except blocks. If you write multiple except blocks, multiple what we call multiple errors will be occurred. So you'll just say value error occurred, and I'll just say please enter in numbers. Okay, I'll tell to my user that enter only numbers. Enter only numbers, something like that. Okay, in this way I'll handle specific exception. So in this case, you can just see I'm handling both file not found error and also value error, both I'm handling. Okay, so just let me run this. You can see if I give hello, if I give I, yes, you can see I'm getting a value error. So here what happens here is, even though there is a error exception here, it will not go up to here, because immediately I got an exception here, it will go to the except block. Okay, and moreover it's like an else condition, like else if condition, like, because just carefully observe, I'll just write this code in the visualize Python, then you'll be getting a clarity. Okay, you'll be getting a clarity how exactly this multiple except blocks works. Okay, so here what happens is, let's assume that you are clicking on next. Okay, it went to try block. So it is first asking me to enter the input. So I'll just say 12, submit. I'll not enter proper input. Maybe I'll just say hello, submit. So now it will try to convert into integers, which is not possible. So you can see here, the moment it will try to convert into integers, here at 7th line itself, I'll be getting error. So the moment I got an error at this particular line, it will never go to this particular part of code at all. It will never check for the file also. It will not open the file also, because I got error at this particular point. That is the reason I would recommend to maintain two different codes. If you have two different codes, I have to maintain two different try blocks. But for time being, I'm showing here right now in this way. So you can see I got an exception here. So now the moment you got exception, it will check all the except blocks. Now, is this a file not found error? No, because it's a value error, right? It was a value error. So it will not go to this particular except block. Is it a value error? Yes, it's a value error. So it will check all the except blocks. It's like a else if. If you remember, we have talked about else if, and if, right? So if first it will check for first except, it's not that particular error, then it will go to second except, it is not that particular error. If you have third except also, it will go to that by chance, if it is not. Okay, by chance it is a value error. Yes, it's a value error. Then it will go to this and finally print that and finally do this. Okay. Now by chance, if I give a proper input here, if I give 12, if I give 13 here, then obviously I'll be getting a file not found error, because this part of code is properly executed. This part of code is not executed because random.txt is not present. So it will go to only file not found error, and I'll be getting this file not found error occurred, and it is creating a new file that is called as random.txt is created. So like that, if you want to handle a specific exceptions also, you can handle in this way using this particular blocks. Okay, and finally, there may be chances where when you're writing a multiple lines of codes, there may be chances where it might be not file not found, or it might be not value, but you don't know what might occur. There may be chances of any other error also. It's not file not found, it's not value error, it might be any other. Then how do you handle that? Then what we can do is, then in this case, I would recommend to add another except block and made it exception. Okay, made it exception. So this particular except block will execute if any other exception occurs apart from a value error and file not found error. Means let us assume that some other error occurred, means maybe index error occurred or some other error occurred, and it is not a value error or file not found error, then this particular part of code will be getting executed. Okay, so let me show you. Okay, I'll just create a sample error right now. So let's say a is equal to maybe list of data 1, 2, 3, and I'll try to slice like this. I'll just say b is equal to a of 4. Now, if we just look at this, here obviously I'll be getting an error, because here there is no problem in syntax. Syntax is perfectly fine, you can see that. But the thing is, here you have not properly the indexing is bad, because here we have only 0, 1, 2 up to 2 index only, but we are slicing 4, which is not possible. I'll be getting an index error. So right now I'll be getting an index error. It's not a file not found error. It's not a value error. So in that case, I would get exception occurred. You can see I'm not getting any value error. I'm not getting file not found error. I'm getting an exception, because if it is not file not found, it is not value error, something should be happening, right? That is exception. And it says index out of range. You're getting an index error basically. So in that way, you can handle multiple exceptions in your Python in this way. Okay, perfect. Now let me show a small code in exception handling. How do you work with a sample exception handling? Let's assume that you have defined a function like this, def add, okay, and you'll just say like this, a is equal to, I'll take the same code only, this particular part of code. And you know, right here, if the input is not proper, I would get the error. So I will try to handle the exception here itself. In the function itself, I'll try to handle the exception. Okay, cool. I'll just say except block, and I'll just say I'm not handling any space, or let me handle a value error only, and let me write the except block here. Okay, so in this way I'm writing a simple add function. The moment I call add function, it'll ask me to enter the input. So I'll just say 12, I'll just say 13. If my input is proper, I would get the number as perfect, but my input is not proper, obviously I would get an error, you know that, right? But if you just carefully observe here, after you handle the exception, you're telling to your user that to enter the numbers, but you're telling to the user that to enter the numbers. But are you giving any opportunity to the user to enter once again? No, you are not giving an opportunity to enter once again. So in this case, recursion will be helping us. I mean, I'm just combining this both. So what I will do is I'll just say enter only numbers. I'll just say please enter only numbers. And I'll give another opportunity to my user to enter only numbers. So I'll call again add. Right? I'm calling my function again in the function. Right? Again, I'm calling add because again I should give the opportunity, right? So let me check how this works. Okay. So first, if I enter number 12, 13, there is no exception occurred. So there is no recursion called, perfectly fine. But if I start giving a wrong input, if I say hello and 12, now I'm saying to my user to enter only numbers, and it is again calling the add function. That's how your code should be. So again, I'm giving 12, and if I give a wrong input again it is giving me an option to again enter a input. So like this, it will go on continuing until I give a proper input. Once I give a proper input, yes, no exception occurred, I'm getting 25. So in this way also you can write a code. So this is how your function works. And you should call the add function only when value occurs. So in that way, handling a specific exception will be helping me. Okay. So this is how your exception handling will be helping you. You can see how exception handling is powerful in these cases. Okay. Perfect. Now I should talk about something called as else block. Okay, we talked about how to handle exceptions, right? Now we should talk about something called as, there is a, when you're working with exception, there is a block called as else block. Okay, what is else block? So what is else block means? I'll just show you, then you should guess it. You can only easily guess it. What is, how else block works? Okay, so I'll take a small example. Let me take this particular small code of exception handling. Okay, so here I'm handling an exception. Very good. Now, if we just carefully observe here, you can write an else block. Okay, there is a chances of writing an else block after try and except. See, we have written else block for loop, while loop. So in every case, there was a reason. Here also there is an else block, and there is a reason for that. Okay, so how do we use else block means? For example, let's assume that I'm writing an else block like this, and I'll just say print this is else block. Okay, this is else block. Okay, now what is the use of this else block? What is the main use of this particular else block means? Just have a look at this. Okay, let me try to remove this and add this, then only I can easily show you. Okay, I'll run this. Okay, first I'll give an input properly, so I'll give 12, 13. These both are convertible integers, and you can see my else block got executed. I got this is else block, right? I got this else block. There is no exception occurred here. There is no exception occurred, and this else block. By chance, if I entered a wrong input, you can see there is no else block execution. So from this, I guess we are clear that else block will be executed when there is no exception occurred. Okay, clearly I can say that else block will be executed when no exception occurred. So this will be helping us to write a specific code if there is no exception. See, for example, let's assume you're writing a specific code and the next part of the code you want to execute only when there is no exception occurred, then you can use else block. Example. For example, if you want to take a specific example where exactly else block is used, let me take an example here. Let's assume that I'm opening a file here. Okay, I'm opening a file here. Maybe I'm not using context managers. For instance, I'm not using any context manager, and let's assume that I'm just saying like this: f is equal to open of random.txt, okay, comma, mode is equal to r. So here I want to close my file only when there is no exception occur, because if there is an exception occur, obviously it means that there is a file has not properly opened, right? So I want to run the else block, or I want to execute the close operation only when there is no exception. Then I can write in else block. So I can just say f.close. Okay. So you can see here, this particular file will be closed only when there is no exceptions. By chance there is an exception here. For example, let's assume that random.txt is not created. Okay, random.txt is not present. Then there is no point in closing the file, right? Because obviously there is a exception there, means file has not properly opened. So obviously I would get an error here. So in that way, you can see there is no else block executed. So I'm not closing the file. So some that kind of operations. So especially else block is used to write a particular code when there is no exception occurred. Okay, when no exception occurred. Forgot to, yeah, cool. So that's the main use of else block. You can see here, in this case, exception occurred because I've just deleted random.txt and my exception occurred and else block is not executed. Okay. Then at the last, we have a block called as finally block. We have one more block called as finally block. That's actually, there is no great usage of finally block. It, as the name says, this will be executed at the last. Means once all your exception handling is done, at the last, if you want to write any specific code, you can write this finally block. Okay, and this doesn't have any relationship with exception and no exception, because even if exception occurred also, your finally block will be executed. If there is no exception also, finally block will be executed. But the only thing is, finally block should be written always at the last, as the name says, finally. So this will be executed after your entire exception handling is done. Okay, this is finally block. Okay, so you can see here, even though exception occurred, finally block is executed, even though there is no exception. For example, if I open with mode X, obviously there will be no exception. So you can see there is no exception, else block executed and finally block executed. So, but finally block will be executed after your entire code got executed. So the name says finally. So if you want to do some kind of any kind of final operations, final code, so you can write in finally block basically. So in that way, we have else block, finally block, and try and except in your exception handling. Okay. So in this way, exception handling works. Now you know how to handle exceptions in your code, either how to handle exceptions by all, or if you want to handle specific exceptions, you know that. And what I would recommend is, whenever you're having multiple codes, maybe let's assume that here we have written multiple codes in one place. Yeah, maybe let's assume like this. Okay. Whenever you're having multiple codes, what I would recommend is to handle exceptions separately. That would be giving more proper insight when you're debugging your code, or if there is an exception. Okay. So in that way, of course, your code length slightly increases, but that will be helping you to handle specific exceptions more clearly. Means what? For example, let's assume this. Right now, what you've done, we have kept all the entire code in one single try block. But this is the more better way is, for example, here there's a value error, right? So you can put it like this, value error. Then you can surround this with another try block. So in that way, this particular code and this particular code will be independent of each other, right? This particular code and this particular code will be independent of each other. In the previous case, what was happening? This particular code will be executed only when this particular code, part of the code, was perfectly fine. But as we have separated this, even though there is an exception here, this particular code will be executed. That is what I want, right? I don't want to make this dependency again. Even though when I'm handling exception, right? So in this way, you're handling two different exceptions, right? Separately. This particular part of code is different and this particular part of code is different. like this. This is one way. This is a general way we can use. So if I say 12 and if I say 13, you can see there is no exception occurred. By chance, if I give a wrong input also, here I'll be getting an exception. In this case, I'll be getting an exception, but in this particular part of code will be properly executed, right? So in that way, you can handle your exceptions. Perfect. Now you know how to handle exceptions properly. That's cool. But generally, when you're working with programming, guys, there may be a situation where, for example, let's assume that you're developing your own library, okay, or you're developing your own software, something like that. And if the user is not giving proper input, or by chance if it is input is invalid, or by chance if you are developing a library and the way you are getting the data is not proper, then you want to raise your own exceptions. Means right now we have seen how to handle exception, but what if you want to raise your exceptions? Means if you want to raise your exception by yourself in your programming, then how do we do that? Means let me just show a small example. Okay, how to raise an exception. How to raise an exception. So how to raise an exception means it's very simple. There is a keyword called as raise. You can use that. Let me show you how can you do that. Let me define a function first. I'll just say define. Maybe I'll just say display. Just a random function I'm displaying. I'm just creating. And I'll take an argument called as maybe a. So the thing is, the condition for this particular function is, if you are getting numbers less than 5, you should raise an exception. Okay. If you're getting any number less than 5, you should raise an exception. So I'll just say if a less than 5, then in this condition I'll try to raise an exception, or else I'll just go on, means I'll just say print a maybe. Okay, so now in this if condition I'll try to write a code which can raise an exception. Okay, so I'll just say raise is a keyword. Okay, space. Now which exception you want to you want to raise? You see you have multiple exceptions. If you just go and just click a tab on this, maybe I'll just show how to see the exceptions also. So if I just click on tab like this, except, and if I click on tab like this, you can see these are n number of exceptions available. Arithmetic error, base exception. So depending upon the error, you'll be getting different kinds of exceptions, right? Different kinds of errors. So for example, let's assume that I want to throw a value error, or let's start with the basic exception. I'll start with only exception. I'll just say like this, raise only exception. So there is no specific name for this right now. It is just an exception. Okay, exception. And like this, something like this. Okay, if I do like this, what happens is, if I call display and if I say 3, I would get an exception. For example, if I say 10, it is more than 5, so I would not get an exception, it will print 10. But if I get maybe 4, I would get an exception, saying that only exception. But there is no message here. We're saying only exception, but there is no message. So if you want to give any user, if you want to give any message to the user, then you can do like this. You can enter like this. Please enter number more than 5, something like that. So you are giving your own exceptions, right? So you can see, I'm just saying, please enter number more than 5. You're giving your own exceptions like this. Okay. Maybe I don't want to give exception here. I want to give value error. Means I want to give a specific error, maybe value error, something like this. Then you can say value error. Raise value error. So you'll be getting a value error. Please enter more than 5. So in this way, by using the raise keyword, you can actually raise your own exceptions depending upon the requirement, if you are have that particular requirement. Okay. So in this way, your exception handling works, guys. So exception handling will be playing a major role in programming, because whenever you want to write a production level code, okay, you need to handle these kinds of, you need to handle exceptions such that you don't face any crashing issues in your development environment. Okay, this is how it works. Thank you, guys.